So, good evening to everyone. I'm quite new here in Brno in Czech Republic, so let me introduce myself. I'm Pietro Messineo and I'm working for Augmented Reality. And I'm quite old about iOS programming. I'm coding since 2012, so I was just a kid, 15 years old more or less. So basically I started coding Siri, but in Italian. So basically I stole Siri from Apple when it was available in English and in German, and I translated it and coded some Python libraries. So just moved after some year, I started to code in Objective-C and then hopefully went out Swift, because how many iOS developers there are here? 1, 2, 3, 4. Okay, so quite a lot. So some alpha iOS developer I seen also. So basically until now I have 7 apps already published on App Store, so that's quite enough. And tonight I want to talk about ice tracking with Apple ARKit. Before to start, we should just do a small step before, and we should better explain what is augmented reality. So I think that most of you knows already augmented reality because it's quite new technology, but it's kind of running on our phones slowly. So it's a new technology that is offering the possibility to place some virtual objects in the real world through the display and the camera of your device. So what does this mean? That you can interact through the display of your iPhone, for example, or your Android device, but I prefer iOS, as you can imagine. So you can just, for example, drag and drop an object, or you can just, I don't know, work around for see how the chair in virtual reality look like. I don't know if some of you seen that IKEA created their own application for see the furniture in real time. So basically this is the best part of augmented realities. So what is ARKit? Basically ARKit is a new framework that went out in 2017 with the release of iOS 11 actually. And a few months ago reached version 3 with a lot of interesting improvements. So what can you do with ARKit? With ARKit, with the version 3, you can even do people occlusion. What does it mean? You can place a virtual object through the camera of your phone, and if there is someone behind this virtual object, it's completely or partially at least covered. So as you can see, there is one guy that is using, for example, his iPhone to place this ball, and behind the ball there is that mirror. So as you can see, it's kind of occluded for the alphabet. But then you can even do motion capture. This is kind of funny, because you can create, I don't know, your own avatar, and thanks to the camera, the back camera, you can understand all the position of arms and legs and copy or clone the same motion on the avatar that you created in augmented reality. Then there is the world tracking. So as I said before, you can just move around the real space or around some virtual objects. And then there is face tracking that is really interesting, because it's not the face tracking that all of you can imagine, because it's not 2D, but it's 3D thanks to the face, the 2-depth camera of iPhone 10, 11, 10s, 10R, and so on. And basically, this screenshot is pretty interesting because this is one of my apps that has been also talked by one pretty important Italian YouTuber. So this app I developed in 2018 in August, and I used it as a thesis also for my bachelor degree. And basically it's working, it's recognizing through the face, the 2-depth camera, the face expressions. As you can see, it will appear that funny face over there, and you need to imitate the same faces that the avatar is doing for proceed in the game. And then you can even do image recognition with it. So basically it's automatically understanding which object is over there, and based on the object you can connect a 3D model to display. And another interesting thing is that if you will move that iPad with the image, as there is an anchor on the phone, on the image of the phone, the 3D model will move along the iPad. So, what's next? As we said that tonight we're going to focus on eyes tracking, we need to start talking, we need to focus on face tracking, and in specific with the class, about the class ARFaceTrackingConfiguration. This class is helping us for face detection and eyes tracking. So, it's like used when you want to track the faces, and it's working only with iPhones, as I said, through that camera, because it's not a 2D, but it's a 3D face recognition. So thanks to the through that camera that is pointing and sending a lot of lasers invisible to the eyes of the humans, it's possible to track a lot of nice informations, like the topology of the face, the position, and some other interesting informations. But for start a face tracking session, it's important, like you can see here on the top, it's important to create a session configuration and then run this session. So this little piece of code is really, really important for better understand if the device is supporting the AR face tracking configuration. Because ARKit is supported by, I don't know, most part of the iPhones from 6S and over, but the face tracking configuration is supported only from, it's supported only by some specific devices that, as I mentioned more times, are enabled through that camera system. So, as you can see in this peak, you can see that there is like, you can track the position and the orientation of the face. I think that most of you use it just for fun, at least once in life, some filter space from Instagram or Snapchat. And you can achieve this using the scene kit, and that is based, of course, in augmented reality. So, thanks to the face tracking session configuration, you can just attach one anchor that is called AR face sensor, and it's automatically rendering every time each frame for have a perfect mask of your face. So as you can see, it looks that for real people have the face painted, but in reality it's just a mask, it's just applied in, through the front camera of the phone. So as you can see here, I mentioned that you must call, after the AR face sensor has been created, you must call the rendered node 4 and the rendered add 4. So just keep in mind these two easy and simple just lines of code and or delegates method for just later, because I will wish to show you also the code of how the demo app that I will show you tonight is working. So, AR face sensor and face tracking, it's important because you can even use it for eyes tracking. So thanks to the AR face sensor, it's giving us the information for about the pose, the topology of the face, and also about the expression, because before I showed in the screenshot that the app is able to recognize which expression you're doing, like open mouth, eyes up, blinking, and so on. So thanks to the property left eye or right eye transform, we can obtain a transform matrix that is pretty important for the eyes tracking, because with not so many lines of code, we can achieve really a lot of important things. Eyes tracking in this particular case. As you can see here in the peak, there is like the eye is obtaining the matrix in the Z that is starting from the eye that can be left or right. It doesn't matter, it will be the same. So you will obtain the Z axis that is pointed at the pupil of your eye. And thanks to this, we can like obtain the direction of the eye, where it's pointing the eye in real time, thanks to augmented reality and ARKit. So now, if I think that there are like quite a good amount of iOS developers, so I will wish to show you how the app is coded, because like really, there are not so many lines of code, there are basically just two classes. So just giving you 1 minute for open the project. I don't know if it's enough visible. So, in our view controller, basically we have the quite most important part. So, there is like a face node created, initialized here, but these things are quite not interesting, or at least not so much. And here you can find declared also the target for the eye, left to right. And then it's important to declare the physical size of the font, because based on the font, it's changing the dimension of the screen. So the eyes tracking could be not so precise. So that's why it's like manually declare the size of the screen. I just want to also say that this app is not finished yet. It's just a demo. It's not available in the App Store. So that's why it's manually declared this. Here I created like the node for the eye, for the left eye, and here the node for the right eye on this piece of code. I'm initializing the delegates that are important for augmented reality purpose. And I'm also initializing the Shin view that I mentioned before, because without Shin view and ARFaceTrackingConfiguration we cannot like do so much with augmented reality. And what else? The app is able to recognize the eyes at 2 meters away from the screen. So later in the demo you will notice that there is a small counter related to the distance of the eyes in real time. So that's quite interesting, because I couldn't imagine before to start to work on this app that you can just stay 2 meters far from your phone, even though Apple said that the good like distance is 1.5 meters. But imagine 2 meters, like it's the hand that is holding your phone here, and it's basically able to still recognize your face and your eyes. So that's quite interesting, because I think that none of the Android devices are having right now any of features like these. I mean 3D cameras, 3D front cameras for Face ID. So I think just 2D. So as I mentioned before, it's important to call the isSupported functionality, isSupported method for check if the device is supporting eyes tracking or no. And then it's important to run the view session in augmented reality. So I asked you just to keep in mind about the delegate render, because as you can see here, it's used for the node transformation for the face sensor that I mentioned multiple times. So you can update multiple times in real time all the nodes in your face for better understand the position of the muscles of the eyes and so on. Because each frame is automatically attaching a new anchor. So then you have also the function update, and you can see here that there are some kind of transformation that I was mentioning before for obtain the matrix of the current position of the eyeball. It's important to like dispatch everything on the main queue, because you can have some problems of priorities in the thread. Then I'm just keeping the position up to 8 present position for like a smooth effect of eyes positioning and eyes tracking. And I'm updating the indicator with the normal like transformation and translations. And what else? What else? I'm calculating the distance of the eyes to the camera, and the average distance from the eyes. So basically, as you can see, it's not so easy. So even though Apple is giving us all the API, all the methods for eyes tracking, what I'm going to achieve tonight, what I'm going to show you tonight, is not so easy that you can imagine like, oh yeah, I can do it. You need to know a bit of mathematics. Yeah, I can just say to you that I was sucking in mathematics so much, but I was able to achieve this. So if in university you are bad in mathematics or you were bad in mathematics, there is an hope also for you. So then here there is the most interesting part, that is basically letting you to scroll any type of documents that can be a PDF, a book, or even like a URL, just with your eyes. So you can imagine, probably you can think that it could be stupid, but imagine people that are disabled, they can just use their eyes for this. So as you can see here, I'm using some of the interesting information that we obtained before about the eye's positioning, and then just dividing the screen in 3 pieces. Upper part, so when the eye is focused on the upper part, you can just scroll up. So if it's between 0 and 700, you can scroll to the up, the page should move to the up. If it's in the middle, just let's stay, so we don't want to scroll on the top or on the bottom of the page. And if you're on the down part, you are just scrolling down. So that's quite interesting, because imagine that, okay, you would see that it's a bit difficult, but if you have, for example, an iPad that is having the Face ID, so the true depth camera, and you're having it in a desk, and you are standing still in front of this, it could work, but you can just, I'm just giving you an option on what you can do with these eyes tracking functionalities, and then it's up to you what you can achieve with this. So once again, we are using the delegate for the render, for the face detection and attaching the nodes. And as I said, we can like read or navigate between documents or even web page. So for achieve this, I'm using a web view, because the easiest way for read a PDF is just calling or just presenting it in web view. And here there are some interesting mathematical equation for just eyes tracking purpose. So what's now? Let's do the demo of the app. Give me 1 second that I will set up the phone. So as you can see, the interface is pretty minimal, because it's just a demo, it's not an app that will be released. I'm not planning to release it, so you can insert an URL, or you can just pick a file from your file app. We will just open this PDF. If you will point in it, you can see that the app is already seeing my eyes, like if I'm Superman, if I'm like shooting some lasers. So as you can see, if I'm watching on the top, so this red pointer is watching on the top, it's scrolling up. If I'm watching down, it's scrolling down. And if, like slowly, of course, because we need to have sometimes read. If I'm watching like on the middle, it's not doing anything. If I'm watching again on the top, it's scrolling up. So basically, you can even, for example, I don't know, let's run some website. So we are in a normal like web research, so it's quite difficult, it's quite challenging to point the eyes in the right place. So I'm watching down and I'm scrolling this website. Strange, this website in particular, I know, but still. So I'm watching down, it's slowly scrolling because you need to have the time to read. Then I'm watching in the middle, nothing is moving because we want to read what was over there. Then we're watching up and it's scrolling again up. As you can see here on the down left bar. Yeah, on the down left part, you can see that there is the distance, because the phone is able to understand how far you are from the phone. So as you can see, it's changing in real time. Does someone wants to try how does this work? All of you are shy? Really? Come on. Come. You can hold the phone with your hands. Okay, so just watch. You should just keep it in front of you. Yeah, and then you need to try to balance your eyes watching on the screen. Yeah, great.
But you must look downward, and now you cannot read the text. Now you can.
Yeah.
Yeah, it's really hard.
Yes, yeah.
If you want to read the text.
You can even zoom in if you want. You can zoom in.
But
yeah.
it all the time. Oh.
Yeah, because if you want to read, you need to focus your eyes in the center. Yeah, as you can see, you're stuck.
Yeah.
You can, if you want to go down, you can just push down and it's scrolling again.
Yeah.
Slowly. Yeah. Yeah, as you can see, it's quite challenging. It's not so easy, but
it's really hard.
Yeah, but I'm just giving you an example of what you can do with what you can do with eyes tracking, augmented reality, and a specific ARKit from Apple. So, from my side, that's all. I hope that you like this ARKit. Do you have any questions? No questions?
There are a few questions on the slide, though, really interesting ones, so we'll just switch the laptops again. Okay, so is it possible to tracking hand and recognize fingers?
Well, I'm not sure, but with motion capture you can basically recognize almost all the junctions of your body. So I guess that very soon, probably this June, you will be able to recognize also hands and fingers, most likely. I'm not sure yet.
Okay, another one. Is it possible to download the demo?
It's not possible to download the demo, but if you're interested to test it out, you can just send me an email at info@mynameandsurname.com, and I can provide you some link and you can download it from there.
Thank you. Maybe you can just repeat during the networking when somebody will invite you for a drink. Okay, is it possible to track where the user is looking on the screen?
Yes, of course it's possible. Probably this question was before when I was doing the just talking during the presentation. That's interesting because some people are afraid about some privacy because they can think that companies like Facebook or other big companies can just track the eyes for marketing purpose. So where the guy is looking on the screen, what he likes, and so on, all the face expressions. But believe me, these things are not happening because when you're using augmented reality, your phone will become really, really hot. So you will notice. And you can still, you need to allow the app to have like camera access for it. So if you will just go on Facebook and disable all the things as I'm doing, like camera, microphone, and so on, you will stay safe.
And I really love the second part of this one. Does it suffer blinking? How will it react to the loss of users' eyes? How, I suppose the eyes will fall down.
Well, yes, it's supporting blinking. If someone is interested in this, I will let them try my application that is about face emotions. So there is also some blinking and some smiles, some open mouth and so on. And what about the loss of the eyes? Well, I never seen anyone that is losing the eyes while using the app, but well, it can happen. And usually, actually, I tested the app on one man that was having only one eye, and actually it's still working, honestly. So, yeah, you can use the app if you have one eye.
Thank you very much. Do we have some questions in the audience? Hands up? So probably not. So thank you very much, Pietro. Big applause for him.